Hello everybody and welcome to this lesson. Today we will discuss about theory of costs. First, cost is defined as those expenses faced by a business in order to get the required resources. As we know, an organization should get resources for the conversion. Organization convert those resources to output or services. So, in order to get those required resources, an organization need to incur costs. So, those expenses can be defined as cost. Let us see types of costs. Costs can be categorized into different types. First, we can categorize as explicit and implicit costs, and we can also have different categorization. Let's see one by one. Explicit cost. It is a direct monetary expenditure, or it is out-of-pocket expense, which is expressed in terms of money, such as materials, wage, interest on loans, rent. We pay money in order to get this firm's resources. We pay direct monetary payment. We conduct direct monetary payment in order to get those resources. This can be called as explicit cost. On the other hand, implicit cost is the indirect and non-monetary cost. It is non-monetary and it is indirect cost that can only be estimated by opportunity cost or the second missed costs, which is the loss of earning due to lost opportunity. By the way, life is full of opportunities, or life is full of choices. If we have two choices, for example, I want to choose one by ignoring the second option. So the second option that I ignore, that I didn't select, is the opportunity cost, the missed opportunity, or we can say the lost opportunity. So this cost is expressed as implicit costs. Majorly, economists consider implicit costs, whereas accountants consider only explicit costs, that is monetary payment, and it is revealed on the receipt. It is revealed or expressed or registered on the receipt. Therefore, economic profit is equal to total revenue minus both implicit and explicit costs. Whereas accounting profit only considers explicit costs. So total profit, accounting profit equals to total revenue minus explicit cost. So we can generalize that accounting profit exceeds economic profit, because accounting profit will not consider the implicit cost, which is not revealed in the receipt. The other types of cost is a sunk cost. This is a type of fixed cost, by the way. It is types of fixed costs that cannot vary with the outputs, that cannot vary with the quantity of the production, and which can no longer recover, and we can't recover for the future. Once we incur a sunk cost, so it's already wasted, it is already incurred. It's a type of fixed cost that can't be recovered, or which is lost forever once paid. Once paid, we cannot get back. Thus, it should not be considered when making a decision to continue investing or an ongoing project. When we decide in order to continue or to stop the project, or in order to continue our operation or to stop, we will not consider a sunk cost, because a sunk cost is a cost which is lost forever, and once we paid, we cannot get back. That's why we will not consider, or it should not be considered when making decision like continuing in an ongoing project or stopping. The other types of cost is fixed cost. We already said that sunk cost is a type of fixed cost. Fixed costs which are fixed in volume for a certain given output. It does not vary with a variation in the output. Whether the output is zero or the output is certain amount, the fixed cost remains constant. Fixed cost remains constant. Fixed cost can be cost of managerial and administrative staff, depreciation of machinery, whether the machine is working, operating, or not operating. So it can incur depreciation. It incurs depreciation cost. And the other types of fixed cost is maintenance of land, can be an example of fixed cost. Salary can be an example of fixed cost. And rent can be an example of fixed cost. Whether we produce or not, we need to pay the rent of the building, the rent of the warehouse. And the other type of cost is variable cost. These are costs which vary with the variation of the total production or the total output. As the total output increases, the variable cost also increases. When the total production or the output is zero, so the variable cost will be zero. And it increases as the output increases. Variable cost includes cost of raw materials, direct labor charges, etc. When we increase the production, we have to increase the raw materials. We have to increase the raw materials similarly. And the other is total cost. This represents the value of total resource requirement for the production of goods and services. And mathematically, we can express total cost equals fixed cost plus variable cost. Fixed cost plus variable cost will give us total cost. The other is average cost equal to total cost divided by the quantity. Q is the total output. Total cost divided by quantity gives us average cost. And the other is marginal cost. It's the addition to the total costs on account of producing and adding one unit. Or marginal cost is the cost of marginal units produced. It is the cost which is incurred due to the production of the last unit. It is the cost which is incurred due to the production of the last unit. Marginal cost can be expressed as change in total cost divided by change in total output, or change in quantity, or change in total variable cost divided by change in quantity. Here we ignore change in fixed cost because change in fixed cost equals zero. There is no change in fixed cost with regard to the volume of production. That's why here change in total cost divided by change in Q equals change in total variable cost divided by change in Q. Total cost equals total variable cost plus total fixed cost. And this can be equal to summations of marginal cost plus total fixed cost. Summation of marginal cost gives us total variable cost. The total variable cost equals summation of marginal cost. So summation of marginal cost means total variable cost. Then this plus total fixed cost, we can get total cost. The other division is short-run cost. Some inputs are fixed in the short run, and the other inputs are variable cost. So fixed costs are costs associated with such fixed input must be paid regardless of the level of output produced. By the way, short-run costs, in the short run, at least we need to have one fixed cost. That means a cost that cannot vary with the output of the production, the volume of the production. In the long run, the other is long run cost. In the long run, all the inputs will be variable cost. That means even the fixed cost will vary, or the organization can get time to expand or to make all those fixed inputs to vary. This is a graphical representation of total fixed cost, total variable cost, and total cost. As you see, this y-axis represents the cost and the x-axis represents unit of output. So the total fixed cost is 6,000 whether we produce 0 output or we produce 600. The total fixed cost remains constant, that is $6,000. Whereas when we produce zero production, the total variable cost will be 0. When we increase our production, the total variable cost starts to increase as per the volume of the production. When we add total fixed cost with total variable cost, we get total cost. So we just move this total variable cost to total fixed cost because of the addition in order to get total costs. This is all about what we have discussed in the previous slide. This table shows how to calculate the average and the marginal costs. If the quantity of the output is given, and if the total fixed cost is given, for example, here in this case, the total fixed cost is 6,000 because total fixed cost equals average fixed cost times quantity. So when we multiply 100 with 60, so the total fixed cost will be 6,000. And the average variable cost is given as like this. Here is the average variable cost. We can get the total variable cost by multiplying average variable cost this times with the quantity. And average total cost is equal to average fixed cost plus average variable cost. And average total cost equals total cost divided by Q. Total cost divided by quantity produced. And the change in total cost divided by change in quantity equals short-run marginal cost. By the way, the change in total cost, for example, from 100 to 60, the change is 40. From 60 to 50, the change is 10. This is an average, right? It's not correct. It's not correct. This is not a change in total cost. This is not change in total cost. So first we have to calculate total cost. In order to calculate the change in total cost, first we have to calculate total costs. Like here the total cost will be average total cost divided times Q. So 100 times 100 will be total cost. Here the total cost will be 10,000. 40. Okay, this is the total cost, and the next total cost is 60 times 200, that is 12,000. 12,000. So the change in total cost here is that from this to this it will be 2000. And the change in quantity is from 100 to 100. Here the change in quantity is 100. The change in quantity is 100. From 100 to 200, change in quantity 100. So here 2000 divided by 100, it will be 20. This one. This one is the change in TC over change in Q. So we can calculate like this. First, we have to calculate the total cost. The total, each corresponding total cost. Then and this is the graphical representation of short-term marginal cost, average total cost, and average variable cost. And this one is the average fixed cost. Actually, the average fixed cost declines continuously as we add more and more quantity. The average fixed cost decline continuously because the average fixed cost can be calculated as the total fixed cost divided by total volume of production. And first, in the short-term marginal cost is below the average variable cost, and when the short-term cost intersects the average variable cost, or when the short-term marginal cost equals average variable cost, this is the point where the minimum amount of costs, the minimum amount of average costs. Here is the minimum amount of average costs. And this intersection is the minimum amount of average total cost. This one is the minimum amount of average total costs. When the marginal cost intersects average cost and average total cost, so it intersects at a point where the minimum amount of average cost and average total cost respectively. Before the minimum amount of the average cost, the short-term marginal cost is below average cost, and after that it is above average variable cost but below average total cost, and after intersecting with average total cost, it becomes above the average total costs. This is what we have discussed. You can reconcile, you can align this with the graphic. And here we will discuss about cost function. It refers to the mathematical relationship between cost of production and the various determinants of costs. There are different determinants of costs. Cost can be explained as cost equals functions of Q, where C can be cost of production, Q quantity of output, F functional relationship between these two variables Q and C. The basic principle of cost behavior is the total cost increases with the increase in the output. We know that the total cost increases with the output because there is variable cost. Even though we consider short term, still there is variable costs that vary with the total production. Here this table shows that short-term costs and the production. Here, labor is a resource, or it is an input. We have to pay money in order to get labor, and these are the outputs, the corresponding outputs for these labors. And there should be costs. We need to incur costs in order to get resources like labor. So here, total variable cost, the total variable cost equals here wage times labor. Wage times labor means the rate or the salary for each individuals, and L represents the number of labors. So this is the total variable cost because it increases as the input increases. As the input of labor increases, the total variable cost also increases. And here it is a total fixed cost equals R times K. R times K. K is a fixed cost where R represents, R is the price of unit of capital service. K is a capital where R is represents the price of the units of capital service. So we can multiply R with K in order to get fixed cost. If we get two fixed costs, so we have to multiply with 2, or we have to multiply with the rate, and total cost will be total fixed cost plus total variable cost. So we get these values. You can see this discussion. If 4 units of labor are employed, the firm can produce a maximum of 100 units. 4 units of labor produce 100 units, and the total variable cost will be 4,000. If 6 units, so we can get 200 outputs, and so on. If the price of the unit labor service wage is 1,000, if the wage is 1,000, so here we get 4,000 for 4, 6,000 for. This is almost the same with the previous table. This is a labor and this is a quantity. This is the average product. The average product can be expressed as the quantity produced divided by the labor, and the marginal product is equal to change in quantity, this column, divided by change in labor, The change, the succeeding change. For example, from here to here, from 100 to 200, the change is 100. All these changes are 100. It increases with 100. And here it increases for 6. For example, here the change is 2, here the change is 3, and here the change is 5, and here the change is 8, and here the change is 12. So we can divide those change in quantity with change in labor in order to get marginal product. And the short run, the corresponding short run costs for this labor is average variable cost equals wage rate divided by the average product. Wage rate divided by the average product. Here is the average product, and the wage rate can be, we can get the wage rate from the previous table, that is 1,000. And here short-term marginal cost will be calculated as wage divided by marginal product. Marginal product is this one, and wage is given, that is 1,000. So we can calculate like this. This is also graphical representations of average and marginal products. Average marginal product first increases, then decreases, and intersects average product at a point where average product is maximized. So this point, that is 800 labor, can make the average product to be maximized. And after that, if we add more and more labor, the average product decreases. And correspondingly, this is a cost curve when the marginal product first increases, then decreases, here the corresponding short-term marginal cost first decreases, then it reaches a point where it is minimum and starts to increase, then it gets intersection, or it gets average variable cost at a point where average variable cost is minimum, and it increases continuously above the average variable cost, By the way, you can see this text. Assume the wage rate is T11. If we assume that the wage rate is T11, so from 0 to 500 units of labor, that means from here, from 0 to 500 labor, marginal product is greater than average product. As you see, the graph is above the average product, and AP is rising, average product is rising. The same is true for the marginal product, is also rising, but short-term marginal cost and average variable cost fails because of the inverse relationship. When the marginal product increases, the marginal cost decreases, and when the average product increases, the average cost decreases. So this is all about these two graphs. This is also the discussion for the previous graph. When marginal product is increasing, the marginal cost is decreasing because of the inverse relationship. And when the marginal product is decreasing, the marginal cost is increasing because of the inverse relationship. And when marginal product equals average product, we get maximum average product. And when marginal cost equals average cost, we get minimum average costs, as we saw from the previous graphs. In short run, the effect of diminishing marginal product on marginal cost of production. In short run, there is a concept of diminishing marginal product because of there is fixed input. Because of that fixed input, which will be a bottleneck for the variable input. So after we increase the variable input, we reach the maximum utilization of fixed input. So after that, if we continue to add variable input, we will start to diminish our product. That is the concept of marginal diminishing product. By the way, this is all about the production and the cost curves that we saw in the previous slides. So you can refer. So here is the main concept. If the labor usage is increased beyond 800 units, marginal product is below average product, and average product continues to decrease, but never becomes negative. The average product never get negative, where marginal product will eventually become negative. If marginal product starts to become negative, so the total product starts to decrease. So during that time, manager who wishes to minimize costs would never hire an amount of labor that would have a negative marginal product, because it decreases from the overall product. If marginal product is negative, the manager could increase output. If the manager gets that the marginal product is negative, the manager could increase output by decreasing labor. By decreasing the labor, the manager can get decrease in cost. So ultimately increase the output. And this also decrease the firm's expenditure on labor. Now let us start long-run average and cost curves. By the way, when we define long run and short run, in the short run there is at least one fixed input, whereas in the long run all fixed inputs become variable inputs. That means the organization get adequate time to change all the fixed input to variable input. So as you see, this fixed curve, average total fixed curve, in the case of fixed input, in the case of short run, this average total cost curve, and this is another average total cost curve, and this is another average total cost curve. So in the long run, the long run average cost will look like this red curve, red parabola. That means first, this is the average total cost, the corresponding average total cost for each production, and this is the quantity produced, this output, the output. The y-axis represents the cost. So this graph shows that as the output starts to increase, as the output increases, so the total cost first decreases, then it reaches a point which is the minimum point, and then the total cost increases. By the way, the shape of the curve in both short run and long run are similar, where the main difference is in the long run, the curve is wider and larger, and these are the different combinations of average total cost and quantity, and this intersects the average total cost curves in the short run. The long run average costs intersects those short run average total costs, as you see. So it shows the different combinations of average total cost and output. This is another concept, that is economies of scale. There are three types of economies of scale. The first is economies of scale exists when long run average costs declines as the output increases. Here, as the output increases, as you see, the output increases, the long run average costs decreases. So this portion is economies of scale, and as the output increases further, so the long run average cost again increases. So here it is a diseconomies of scale, and these are the long run average cost that is constant. So we call it this constant return to scale. Exists when the long run average costs remain constant as the output. And the other portion is learning curve. By the way, this one is an important portion. The relationship between increased per worker productivity and reduced per worker costs at a fixed labor price associated with an increase in output and experience, called learning curve effect. By the way, when an employee becomes experienced, when an employees are doing the same thing again and again, they become experienced, they become an expert on that particular activities, so they can produce more and more with a fixed salary or a fixed input. So that's called learning curve effect. The learning curve effect measures an increase in per worker productivity. The worker's productivity increases because of the skill, because of the experience, regardless of the salary. The worker's productivity can increase. It can be achieved by employee training or off-site continuing education program, adoption of new production system, organizational and managerial technique, replacement of higher costs with lower cost materials, and new product design, and so on. So the learning curve effect can be achieved through these methods. Without increasing the fixed input, we can increase the productivity, and ultimately we increase the total product. This section is an empirical estimates of production and costs. Empirical production function is a mathematical form of the production function which can estimate the quantity produced, or which is a function, quantity is a function of the determinants or the resources, we can say. This is a cubic empirical specification for short-run production function, for long-run cubic production, and we can get short-run production by making one input constant. As we know, there are fixed input in the short run, whereas all the inputs are variable input in the long run. So this equation is the long run production function, the cubic form of long run production function, holding constant, holding capital constant, that is K. When we make K constant, the short run cubic production function can be derived from the long run cubic production. We make this constant, so it will be AL cube plus BL square, because we consider that K is constant, so it will be merged with a constant number, where A equals AQ square, this one, and B equals BQ square, AQ cube, AQ cube, this AQ cube, I want to say that, and this is B equals BQ square. Average product equals quantity divided by labor, so this equals, quantity is this one, L cube plus BL square, so divided by L, so we get AL square plus BL. And marginal product is the change in Q divided by change in L, or it will be the first derivations with respect to L, the first derivations of this one. When we derive this one, this will be 3 times AL square plus 2BL. This is the short run marginal product. This graph shows the average product and the marginal product. By the way, using differentiation, we can get the maximum point. For example, here is the marginal product. The maximum point of the marginal product can be obtained through differentiating the marginal product and equating to 0. When we differentiate and equate to 0, so we can get the maximum point, that is LM equals minus B over 3A, this point. And in order to get the maximum point of the average product, we can equate AP with MP, average product with marginal product, or we can differentiate average product and equate with 0. So we can get the maximum point of the average product, that is LA equals minus B over 2A. This minus shows that the parabola is opening downward, because both curves of MP, marginal product, and average product is opening downward. So this negative sign indicates that. This negative sign indicates the downward opening of those parabola. Estimation of production function. Linear production function can be expressed as Q equals function of K and L if we assume that there is two resources, that is capital and labor, and these are the constants. For example, Q can be expressed as 4K plus L. Capital is always 4 times as productive as labor. This equation indicates that capital is always 4 times as productive as labor, because here capital is 4 times. And the marginal product of an input is simply the coefficient of the input in the linear production function. When we derivate this, we can get only this coefficient. So the marginal product can be obtained through derivation, so we can get the coefficient. So the marginal product of an input is independent of the quantity of the input used, because when we differentiate, we only get the coefficient. So it is independent of the quantity used. Linear production functions do not obey the law of diminishing marginal product. Linear production functions do not obey or do not respect the law of diminishing marginal product, because as we increase the input, the output increases continuously. But in the law of diminishing marginal product, as we continuously increase the input, as we continuously increase the resources, after some time, after some point, our total product, our total quantity will start to decline. That is what the law of diminishing marginal product is talking about. But the linear production function does not obey the rule of the law of diminishing marginal product. This is an example of production function, different power function. For example, Q can be expressed as AL raised B if the exponent is, that is B, is greater than 1, so marginal product is increasing. If B equals 1, marginal product will remain constant, and if B is less than 1, marginal product is decreasing. So this is an example. So you can derive if B is greater than 1, that means if it is 2, so when we derive this one, we get 6x. So when we increase x, so the marginal product will also increases. This, when we derive this one here, marginal B is equal to 1, that is component exponent of x is 1. So when we derive this one, it will be 3. So it is constant. Marginal product is constant. And when it is less than 1, that is 1 over 2. When we derive this one, this will be 3 over 2. No. This, by the way, it follows another form. So it will be decreasing. Differentiation of this will be done through other methods. Anyway, when we derive this one, it will be decreasing. This is an example. It's a solved example, so you can do by yourself. You can exercise. If you have any question, you can put a comment below. This is also another problem. You can do it by yourself. If you have any problem, you can contact me. This is also an exercise. Okay, this is all about today's discussion. If you face any problem while doing those solved exercises, those solved examples, so you can put a comment on the comment box. And have a good time. Thank you.